Hello, everyone. I'm really glad to be here with you because today that we are going to have a webinar for discuss about how our Series 135K, our products from SINEXCEL, that how the product is powered by Infineon's silicon carbide products, and also how we are going to empower the U.S. MPP projects, especially with our local EMS partners to get to the intelligence. So in today's webinars, let me introduce who we are. So first one is my name is Eric. I'm from SINEXCEL. I'm the product engineer for the solution team. And we also have Adam with us, who's the CEO from the Molecule Systems, and also Jonas, who's the CTO from the Molecule System. And also we have Marco. Marco is he's the application marketing manager from Infineon, and also Jonas, who's the product application engineer from Infineon as well. So this is the beginning. So let's start to begin to have a discussion with what we have. So in today's webinars that we're going to have 5 parts, and that we will begin with brief introductions, who we are, and also we have Adam to help us to give a brief introduction about the VPP markets, and also we will introduce the 135, and also we talk about how Infineon's silicon carbides help us to improve our products. And finally, that we have Jonas with us, that who can introduce the real-world deployment with the SINEXCEL's collaboration and also their systems. And finally, we'll have some Q&A sections. So the first part, it is we were going to begin with a brief introduction about SINEXCEL. So our business that we first of all, that SINEXCEL, we were having 4 different branches. The first one, where I'm come from. So I'm working for the energy storage system. So we produce with the PCS and the PCS solutions. And then we have the power quality, and the power quality is where the SINEXCEL we were basically come from. And we also have the smart charging, the EV chargers, and also we have the battery testing systems. And right now we've been into the industry for 18 years. Then our products have been served in the countries for more than 60 countries. We also have 600 partners all around the world. And right now, in the calculation that we already have 5,000 projects already running on site, and some up to 8 gigawatts of the PCS have been shipped abroad. And right now we've been working with 20 gigawatt hour of the batteries. So this is what we have right now, that we were going to be a global company. So basically that we were located in Shenzhen. Here's where our headquarters in Shenzhen. But also we have the factories in Suzhou and the Guizhou factories. And also right now we have our R&D team both in Shenzhen and Xi'an, which one is close to the universities, that we can have a higher educated engineers to join us. And also from out of China, that we have our office in Düsseldorf and Wiesbaden in Germany, and in California in the US. And also we have office in Brisbane and Singapore. And so as I said, that SINEXCEL we have 4 different business. And at the beginning, we will start from the power quality. So we were founded in 2007, and then we joined to the BEST system in 2011. So it means that we already have over 15 years for our experience in the BEST system and the PCS manufacturing, and we are going to be listed in the Chinese stock market in 2017, and then we at the 2023 that we achieved our first target, that we already shipped over gigawatts in 1 year. And also in 2024. Right now, we have been the number one in the Chinese CNI storage market, especially for the modular solutions. In 2025, we launched our latest new product, the 135K. So even though that today our main topics that the PCS we want to introduce is the Sirius 135, but we also want to mention that SINEXCEL we are providing with a whole different wide range of the PCS, and also that we can provide not only with the PCS but also the DC-DC converter to have the hybrid system, and also for the like all-in-one hybrid cabinets. So our products covers the power range from 30 kilowatts to 1.7 megawatts. So we have different types of it, like we have the small modules, and also we have the cabinets, and even we can provide with some turnkey solutions. So I just finished my part for introduction for SINEXCEL. Welcome, Marco, to have a brief introduction for the Infineon's part. So that's welcome.
Yeah, thank you, Eric. Yeah, I'm happy to represent here Infineon Technologies AG. So we are a German company based in Munich, and we are a world leader in semiconductor solutions. And we think that our semiconductor solutions that can make the life easier, safer, and greener. So really, with the microelectronics from Infineon, it is a way to a better future, we would say. And we as Infineon, we position ourselves in key growth areas, such as in energy, like here in energy storage, but also mobility and IoT. And we have a huge global presence, I would say. So we have almost 60,000 employees and several R&D and manufacturing locations around the globe. So from Asia to EMEA, but also the US, both front end and back end. And yeah, of course, you don't have to trust in what I am saying, but also external studies here from Omdia show that Infineon is a trusted semiconductor supplier, and we are currently holding the leading positions within the automotive segment, the power semiconductor, and the microcontroller market. Yeah, thank you.
Thank you, Marcos. And after introduction with Infineon and SINEXCEL, that's right now we are welcome Aidan to give up an introduction about molecule and also about the VPP market. Please share your know-how on the market. Thank you.
Yes, thank you. It's a pleasure to be here. My name is Adam Boucher. I'm the CEO of Molecule Systems. We specialize in site control and economic optimization. Developers love our product because, especially in the commercial segment, every project's different, and so having that flexibility is really, really important. We've had the pleasure of working with SINEXCEL for about 7 years, and then more recently did a seamless integration with their most current product line, so we're really excited to also share some of that with you. But yes, we were able to optimize both for behind the meter savings and optimization, as well as front of the meter. So virtual power plant revenue is now becoming front and center, and we'll talk more about that in future slides. But yeah, at the end of the day, site control is key, and we're working well with the SINEXCEL products to do that.
Thank you. We are also excited about to working for the future. Yes.
Absolutely.
Yep. Okay. So that's okay. We continue with the second part that we are going to the background introduction to the VPP market in the US. Please, yeah.
Yes, it's probably no surprise to most people listening in here that a lot has changed recently in the US market, especially when it comes to the investment tax credit and tariffs that are putting a lot of pressure on margins, and also really challenging project economics. The good news is the new upside, I would call it, are VPP revenues. Right, there are a lot of the U.S. grid is transforming really quickly. Electrification is underway, And most OEMs and device manufacturers at this point really see that their products need to be grid flexible in order to be competitive. You can't just plug in anything you want anymore. You have to be able to respond to how the grid, based on the grid's needs. So in light of the fact that we're losing, when you add up the tariff impact, as well as the pretty rapid phase out of our investment tax credit, that's a 54% margin hit for sort of battery enabled projects. Virtual power plant programs really have the ability to close that gap at the project level so that developers can still present a very compelling return on investment to their prospective customers. So really going forward, rather than being focused on incentives, it's really about revenue generation. And that's what market participation is all about. So it's really becoming a necessity going forward.
Thank you.
So, from the perspective of a manufacturer, when we talk about VPP-ready and you have a VPP-ready product, oftentimes that is a cost center. There's a lot of work, integration work that has to happen in order to bring a device into a market and make sure that it's performing the way it should. So what I wanted to talk about today is a new platform that Molecule is offering called Dividend VPP. And it's really designed to reflect the state of affairs in our market that I just discussed, and focusing on how do we 2 to 4 times, generate 2 to 4 times more recurring revenue utilizing the same battery storage asset. So I'll just describe how that works here in California. But most of the time, when a device is enrolled in a VPP program, it's enrolled in one program. In California, for example, we have something called the DSGS, and it's probably the single most highest paying program in the California market. And so that's what most batteries are enrolled in. But the reality is there are 4 other programs in California that are 2 that are wholesale and 2 that are retail virtual programs. And when you're able to provide the site control, right, meaning that you can ready your assets for an event, and when you can forecast, when when these events are coming, and then if you're able to optimize, meaning you're able to actually stack the events, right? So what we're finding is that when you have site control, you combine the forecasting, so you're preparing the site, the battery is fully charged, you know exactly when the event's going to happen, and then during the event, these events can range from 2 to 4 hours generally. But during that, we are actually doing active energy trading based on algorithms. So this is real-time energy trading. And then there's a settlement process thereafter. But when you so in California, let's say, just using a residential system for simplicity's sake, let's say the DSGS program pays out a maximum of $1,000 a year for VPP participation. If you actually do it via Dividend VPP, where we are doing forecasting, optimization, and site control, and participating in the other 4 programs, we can generate $1,500, right, a year. And the reality is that the $1,000 that you would see on the other side here on the black column, most of those systems are actually generating maybe $500. So they're not even able to achieve the full value of the program. So again, when it comes down to the system itself, right, the BESS system itself, having it fully integrated with the EMS that has full site control, and you layer in those other capabilities, we're able to literally 2 to 4x the revenue. And that makes a huge difference in project economics. And just one last thing, that revenue comes in every year. So it's annual recurring revenue. Right. So that will cause and is causing strategy in terms of development strategy to shift a bit. And again, as we stated earlier, shifting more towards revenue generation as opposed to leaning on incentives that are now going away.
Yes. Thank you. It is really appealing because usually when we describe how the whole BESS system work, like dividend VPP is like the brain. So we have the good brains, and right now that we need to have the PCS, the body should make some difference. So
Absolutely.
So we also make some comparison between the traditional CNI storage, the PCS, and also coming up with a new requirement for the VPPs. So firstly, that in the old time that for the CN9 storage, usually they be slow responding, that even though we have a great brain, but if the body is not working well, so it doesn't make sense. And also the non-standard protocols and hard to be integrated, and also the low efficiency, and there's no hybrid solution. So this is the limitation for the old time for the traditional CN9 storage. So for the VPPs, not only for these old time requirements, but we are also requiring for these 4 different characteristics. Firstly, that we need to have the fast charge and discharge and responding time. And secondly, that we will need to have a standardized communication protocols that we can help to have more frequent, smooth collaboration with the EMS and get controlled perfectly. And then we need to have the high efficiency. And this will be also really related to the revenue that the customer can have. And finally, that we want to add the solar, like we can have a more flexible system that we can make it with the hybrid system to use the PV, or even the renewable energy to charge the battery and discharge the grid. Yeah, so this is the beginning at the beginning of the last year, that we want to develop our 135. And so right now it is our honor that to tell everyone that right now we have our 135 and is ready for the global market, and also it is really ready for every different kind of the scenario. It's not only buying the PCS for a specific function. We're going to deliver to the customer something like an asset that the customer can also not only to fulfill their function requirements, but also they can use the PCS to have new applications. Like we can also introduce the VPP to their system and have more revenue comes. And finally, we will have our 135 that will have a better management on our life cycles, and we'll make sure that it can have the better improvement for when it's being applied to the market. So this is introduction, some brief characteristics for the 135. But today, because we want to mention about the VPP-ready, so we were talking about the specific scenario for the PCS working. So firstly, we want to emphasize is that our PCS 135, it can respond within 15 milliseconds, which means it is not only for the a low speed frequency regulation, but it can also participate into the fast frequency regulation, the primary frequency regulation. So that means we are providing with more capabilities for the VPP projects. And the second idea is that the 135, we are not only working as a charging and discharging from the grid, but we can also to create with the diesel generators, and also we can have a hybrid system, because that we know from the some of the VPP projects, there's a limitation, for example, if the battery it is fully charged or the battery is empty. In that case, the project, the system is no longer to contribute to the VPP solutions. So right now we have the good brains from the dividend VPP from molecules. But right now, what the PCS should do is we are going to have a better architecture, that we are going to have the diesel generators to charge the batteries. And also we can use the PV, the solar power, to charge the battery directly. So in this case, we can have a better management, not only for the battery, but we can have the solar and other energy, and to make sure that we are always working for the VPP plants. And finally, it's because the VPP that it is really scalable. So we know that not only the 4 megawatt projects is working, so our 135 we can serve for the minimum system for 135 kilowatts. And then we can also parallel as much as the PCS to contribute to a 1 megawatt system with only one EMS control. So we can say that we can create 1 megawatt VPP stand, and we can also parallel many of these stands together. So there were lots of plants make up together. So this is how the VPP work, right? And also not only for the VPP scenario, we can also have different types of the characteristics. And also about when we're talking about, because in the US market right now, we know there's a challenging from the tariff, and we want to have the more better revenue margins. So if we are going to use 135, we can have a higher efficiency that we can ensure that there will be more energy can be used. And also because thanks for the silicon carbide from Infineon, because we are having better switch components, then we can make our size even smaller. So this can also help our customer to integrate to their really integrated system to make the footprint as small, so they can save more cost from the projects. And yeah, so we mentioned about, like I said, that we were really thanks to Infineon's contribution for our secret components. So we want to have Marcos with us to introduce how Infineon help us and who Infineon is and how that they're great in the market.
Yeah, I mean, let's have a look here at the core technology that is powering here SINEXCEL system. So you said already this is silicon carbide, but I also want to introduce here Infineon. We are a power semiconductor supplier. Especially here in the power semiconductors, there are different materials. So silicon carbide, and gallium nitride. And we are really playing in all these fields. So we're mastering all these technologies, and we are also an innovator in these topics. Here you can see some examples, for example, the thinnest silicon wafer. We have also a really broad portfolio that really lets system developers drill down their system to their needs. And then also for the next generation of wide bandgap material here, gallium nitride, we have very much IP in this field. And we are really happy here also to see that SINEXCEL is using this technology to enable their system. So when we look at silicon carbide, and you can see it here in the middle part, in the comparison towards silicon, based on the special material properties, you're really able with this technology to shrink the design. So first of all, because of the behavior of the material, but also when you include here also the diet. So then you can get with the same, let's say, or with a smaller footprint, the same power. And this also goes then into the passives and also the cooling. So and for battery energy storage, especially in the commercial and also in the utility segment, I think this is key because it enables also system developers to bring more power at the same size, or use also the volume then more effectively. Yeah, and this originates then from the material properties. So with silicon carbide, you can switch at much higher frequencies, and this shrinks also the passives and also the weight of the design. You also get an efficiency increase. So on one hand side, you get, let's say, 50% less losses usually with silicon carbide. This provides you, in the end, 2% maybe additional energy without increasing the battery size. But on the other side, also the thermal stress and also the cooling, so the overall round-trip efficiency is probably higher with this, and also the effects on the semiconductor at the core, so that the devices are stressed, is lower. So this contributes to an overall higher availability of your system. And yeah, of course, we are not the only ones working in this field, so there are other suppliers as well. However, you must understand also that silicon carbide comes in different flavors, you can say. So we provide a so-called silicon carbide with trench structure. And here you need to understand, so you see this also on the right-hand side, so the different technologies, silicon carbide trench, silicon carbide planar, and then we have the let's say, mature technology, IGBT here. And especially the silicon carbide trench is more challenging to manufacture, but it has better properties compared to the silicon carbide planar. And so we really found a sweet spot here with the silicon carbide. on the efficiency side, but also on the robustness. And on the bottom here, you can see an internal study also from us. So we were checking our devices and the defects per million. And here we can see that for the silicon carbide, which is, let's say, an innovative technology compared to the silicon, which is quite a mature technology, we even see less defects in the fields than for the silicon. And so customers can expect here to get the highest reliability and even better performance than for silicon. Yeah, with this, I would say I'm handing over to my colleague Jonas, who will give you more details on the specific module that is driving here SINEXCEL system. Thank you.
All right. Thank you, Marco, for the introduction. Now, let's take a closer look at the core semiconductor of the Sirius 135K, the Infineon Easy Half-Bridge module featuring our cool SiC M1H technology. Our Infineon Easy modules are the benchmark products in the semiconductor world. We are enabling easy PCB design with a flexible pin grid system. We featuring our press fit technology. This allows a reliable cold welding connection of the module and the PCB with a very low contact resistance. The easy modules come with a base plate package design with a harmonized product height of 12 millimeters, which reduces the assembly efforts in the customer's production line and enables a great scalability of the customer systems. Especially for energy storage applications, I want to highlight our cool SiC MOSFET technology in 1200 volts. With our front-end and back-end investigations, Infineon offered cutting-edge technical solutions like the combination of easy modules with our known cool SiC MOSFET. Whenever we talk about cool SiC, we not only talk about the improvement of the RDS on, but we also talk about the improvement of RDS on times A. So the power density is improved. With this technology, the M1H technology, we allowed a wider gate source voltage area for higher flexibility and easier design in. The customer is able to choose the gate voltage between 18 volts for lowest RDS on values, or choose the known 15 volts to get a short circuit capability. At the same time, with our technology, we allow the customer to use the chips to a junction temperature of 175 degrees in overload conditions. So it's a perfect fit for energy storage solutions, which can use these overload conditions of the chips itself. Infineon rolled out our portfolio, so we have a broad range of chips available covering the whole industrial portfolio, and we improved our gate oxide, which is a known critical point for silicon carbide technologies, to gain unlimited reliability. So combining these two things, Infineon's easy module and our cool SiC technology, we developed the Infineon half-bridge module FF6 MR12W2 M1HB11 for this energy storage systems. This solution, with its low stray inductance and symmetrical layout, enables faster switching and lowest switching losses, bringing SINEXCEL Sirius 135K to the next level in efficiency, lower cooling effort, and a smaller footprint.
Thank you.
That's everything from my side. Thanks.
Yeah, thank you. It's really comprehensive because these three strengths makes us really confident in the market. So right now we're going to our the part 4 that we'll welcome Jonas from Molecule to introduce the real-world deployment.
Thank you. Thank you. Yeah, this is a project we did in partnership with SINEXCEL products, and it was a very successful deployment here in Southern California. So this is a commercial project where the goals were demand mitigation and resiliency. Next slide. And so the fact of the matter is the rate tariffs are ever evolving. I think the utilities are constantly moving the bar as to how they're charging for both demand and energy. And so the necessity for intelligence at the EMS level and is becoming important. And so we have the ability to utilize both 24-hour scale from savings or an offset of demand charges. We're seeing energy and demand being charged both delivery and generation rates, which is used to be that on the energy side, but now we're seeing that on the demand side as well. And so in this use case, there's the EMS is doing dynamic discharge during the 4 to 9 p.m. peak pricing window, and then it's charging during the solar production window. And so the goal is that we're reducing the peak demand 100 kilowatt during the peak window. Seasonally, in the demand charge is really expensive in the summer, but there's also revenue generating opportunities in the summer as well. So with a dividend VPP strategy, there's this flexible ability to have events where we're creating revenue generating opportunities, and then there's events where we're offsetting tariff costs as well. So next slide. This example shows, the normal use case where we're offsetting the demand during those 4 to 9 p.m. peak window events. And so the three numbers show the large discount of demand every day from 4 to 9 p.m. So here the graph shows the solar production. It shows the demand discount. And if you go to the next slide, it's interesting to see this from the utilities perspective. So this is really what the utility meter sees. It's a definitive reduction in demand where the demand is carved out, and then wherever it's white is energy that's being produced provided by the solar. So the EMS in conjunction with the SINEXCEL product is offering 24-hour seasonal benefits to the client, both in offsetting energy costs, but also generating revenue with the VPP opportunities. Next slide. And so one example on the summer demand charge savings would be, about a $3,600 demand offset because they have a large demand peak charge. That cost is not as high in the wintertime. And so the dividend VPP technology would favor revenue opportunities in the winter and favor demand in the summer, unless there's a large event where it may generate more revenue in the summer. And so it's going to flip-flop based off of the highest benefit for the client. So that's the partnership between the opportunities and the technology with dividend VPP, Molecule, and SINEXCEL.
Thank you.
And that's my slides.
Yeah, thank you. So we're going to our fifth part. So if you have any questions to us, then we are really happy to discuss this in here.